Hi there. Let's take a look at the idea of the order of operations. Suppose you're taking a walk through the park on a nice afternoon and someone says, oh, that equals 3 plus 4 times 5. And you want to understand what they're saying. You want to think about what they mean, and it becomes a little bit of an issue because there are two operations. And so we can't do them at the same time. We have to decide which one should come first and which one should come second. And so we need to think about the order of operations. Well, one way to clarify the order of operations is by using grouping symbols. So I could add parentheses around the 3 plus 4 and then times 5, or I could add parentheses around the 4 and the 5 and end up with 3 plus 4 times 5. And so that makes it clear because we always do what's inside the parentheses first. So in this first example, we would take 3 plus 4, which is 7, and then multiply that times 5. 7 times 5 is 35. In the second example, we would take 4 times 5 first, which is 20, and then add that to 3, so we would get 23. But the question is, what do we get if we don't have parentheses? We'd like to be able to interpret the expression even without parentheses. And so we have to decide, and it turns out that the decision that's been made among the mathematics community is that 4 times 5 should come first. And so to be consistent in the order of operations, to be consistent about what this expression represents, we do multiplication before addition. So one way to describe that, we can say that the multiplication has a higher priority. And so with parentheses, we could do the operations in either order and use parentheses to highlight that. But without parentheses, we know that the multiplication should come first, and so we do end up with 3 plus 20, which equals 23. And so it agrees with the parentheses around the 4 and the 5. The 4 times 5 comes first. So I'd like to take a closer look at order of operations and get into some more details about that. Before we do, let's talk about exponents. You may already know about exponents, so forgive me if this is boring for you, but exponents are a way to summarize multiplication. So for example, if I want to multiply the number 2 with itself over and over, so I'm using a dot here to represent multiplication. If I want to multiply 2 with itself, let's say 5 times, it's the same operation, and it's a pretty friendly operation, so I could just take 2 times 2, take that result, times another 2, take that result, times another 2, and so on. So I'm multiplying 2 with itself a bunch of times. Well, we can use exponents to summarize that and say this is 2 raised to the 5th power. And if you work out all those 2's, we would end up with 32. So exponents are a pretty handy thing, right? Especially if we wanted to, let's say we want to take a whole bunch of 3's and multiply them together. Let's say I want to take 7 3's and multiply them together. Well, then what would I do? I would take 3 raised to the, I'd put a 7 up here, so 3 to the 7th power. Let me try to write a better 3 and a better 7 there. That was kind of a mess. 3 raised to the 7th power. Well, since exponents are a summary of multiplication, and we've already mentioned that multiplication has a higher priority than addition, exponents as a summary of multiplication, you might guess, they even have a higher priority. So if we have exponents within an expression, we need to handle them even before we do multiplication. So let's take a look at the general rules for order of operations. So the very first thing we want to deal with is grouping symbols. And after we think about grouping symbols and follow what those tell us to do, we want to evaluate exponents. And after we've dealt with exponents, we can move on and think about multiplication and division. And when we tackle those two, we look at them from left to right. So we work across the expression from left to right. And then finally, we can deal with addition and subtraction. And in a similar way to multiplication and division, we can deal with them from left to right. So exponents have a higher priority than just multiplication and division, and those two together have the same priority, and then addition and subtraction likewise have the same priority. So let's look at some examples. The first example I'd like to take a look at is 7 minus 2 to the fourth power plus 5 times 8. So looking at this expression, there are no grouping symbols, so we don't have to worry about that. So we move on in our order and we think about the exponent. So the exponent comes next. So something important to recognize is that when you have an exponent in an expression, it only applies to the closest thing. So it only applies to the 2, and the minus, that comes after. We think of that separately. So the exponent 2 to the fourth power, well, we said a moment ago, that means we repeat multiplication how many times? 4 times. And so that's going to equal 16. So this expression is going to be 7. We still keep the minus sign. It's positive 2 times itself 4 times. 7 minus 16, and then plus 5 times 8. And now we look at this expression and think about, what should I do next? What would be the next operation that I should tackle? So the dot here represents multiplication, and that has a higher priority than the other operations. Subtraction and addition have a lower priority than multiplication, and so I want to multiply. So I have 7 minus 16 plus 5 times 4 is 40. And now we can work on addition and subtraction from left to right. So together, I can deal with the subtraction first and then with the addition. 7 minus 16 equals negative 9. Negative 9 plus 40 equals positive 31. So what I'd like to do is give you a couple of examples, and I encourage you to pause the video and try to work out the solutions on your own, and then I'll explain them in just a little bit. The two examples are 4 plus 6 times 10 minus 3, and 6 times 9 plus 2 to the second power minus 5. So do take a minute, pause the video, try to work out the answers on your own, and then we'll work it out together in just a little bit. Well, I hope you took a moment to work out the solution on your own, to try to figure out the answers to these on your own. Let's look at the first problem here and see what we can come up with. So we have a bunch of operations, we have some grouping symbols, and so we know that we want to start inside the grouping symbols. So I'm going to get 4 plus 6, and then inside the parentheses, 10 minus 3 becomes a 7. And so something else you might know is that 6 sitting next to parentheses like that, that also means I want to multiply. So if there's a situation where there's not a clear operation symbol, it means multiplication. And so that has the higher priority. So I want to take 4 plus 6 times 7 is 42, and 4 plus 42, of course, is 46. In the second expression, again, we have even more grouping symbols, and so let's take a look at that and think about what we want to do first. Well, I have these brackets. Inside the brackets I have parentheses, so this is inside the deepest set of grouping symbols, so I want to start there. So we do the addition first. Of course, 9 plus 2 is 11. And then we're going to subtract 5 from that after we square it and multiply by 6. And so now the parentheses really aren't doing anything. So this really means the same as just 11 squared, which of course is 11 times 11, or 121. So we have 121 minus 5, and then we still have those brackets, and then a 6. So 121 minus 5 is 116 times 6. And I worked this out ahead of time, but it turns out 6 times 116 is 696. So I want to talk a little bit more about grouping symbols and then look at just a few more examples. So there are some symbols that just represent grouping symbols. So things like parentheses and brackets. And I don't use them for this very often, but curly brackets, braces, can sometimes be used to represent grouping symbols the way we've seen in the examples in this video. But there are a few other symbols that also represent grouping. A fraction bar, a big fraction bar, can sometimes be used to separate different expressions in the top and in the bottom. And we need to deal with those expressions separately before we combine them. So the fraction bar essentially represents a grouping symbol. And also a square root and absolute value can represent grouping symbols. So these are special because they're grouping symbols, but they also represent operations in and of themselves. So we have a fraction, a square root, and an absolute value. And so for some of you, this might be, these two especially might be new ideas. But I wanted to look at a couple quick examples to show how these grouping symbols are used. The first example I want to look at is 15 times 3 over 4 minus 1 squared. And what we just said about a fraction bar, that represents a grouping symbol in the sense that I generally want to deal with what's in the numerator first, and then deal with what's in the denominator second, and then if we can deal with the division in between and try to combine the top and the bottom. So in this case, the operation up top, there's only one of them, so 15 times 3 is 45. And the operation in the bottom, well, now I do have a couple of operations here, and so first I want to do subtraction, since that's inside the parentheses. And then that's being raised to the second power, and just like we saw with the 11 a moment ago, once we have just a single number inside here, I don't really need the parentheses anymore, so I have 3 squared, which is 9, and so my expression becomes 45 divided by 9. Of course, we can do that, we can calculate that out, and we get 5. Alright, so last two examples, I'd like you to pause the video again, try to work out the answers to these. I'm going to share the answer in just a moment, but I'm not going to work through all the steps. So if you have a question, you might want to add a comment to the video, and good luck. So here we go. The first one is 30 plus 4 times 9 minus 8 divided by 2 raised to the third power, and all of that is over 5 minus 3. And in the bottom we have 13 minus, in brackets, 10 plus 8 minus 3 squared divided by 7. So pause the video for a second, try to work out your answers to those. Well, it turns out I think the answer to the first one here, the number should be 265. The answer to the second problem is 8. So if you think I got the wrong answers, let me know in the comment section. I hope you enjoyed the video. Thanks for watching.